Hi, so now I'll show how to configure your PLX31 EIP Ascii. So first I'll show you what to do in your ArcLogix project. So you want to add the EIP Ascii module over here. So just go in module. And if you have the ESD installed, then you should be getting the option over here. So once you have selected that initially, you need to so now you need to configure the IP. This one is the one you set for your through your PCB for your gateway, and this one this option will allow you to change the number of IO connections you want to set up. So let me just show you with one IO connection. Okay, so then before I jump into this, I first want to show you the PCB configurations. Okay, so you need to add this module PLX31 EIP Ascii. For the class 1 side, you don't really need to do anything because this one is just server. And over here, as you see, this is the input data from this example, starting from 0, and the output is from 2000. So for this tag over here, this one will be going to internal address 2000 in the gateway, and this one over here is going to come from internal address 0. So now that we have that set, so let's go to the ASCII port. Okay, so you need to enable it, and this is dependent on your device. So in your device, I see it can be configured for all three. So you can, depending if you're using 232 or 485, you just select that. Okay, and this one is coinciding with EIP connection, class 1 connection. So the one I read from the ASCII port is directly being transferred to the input, and then the one that I'm sending is in the transmit for the ASCII. So they'll coincide and you'll see data transfer as expected. Okay, so this is the baud rate again from your ASCII devices. That all these configurations will be set from your device. So, and the parity, the data, and all the serial settings. Okay, so now this one is the one you need to set according to your frame format. So this is the user manual for your device. So I'll give you an example. Okay, so this is one for reading. So over here, this is the one being transmitted from the host to your device, and this is the one that your device is sending. So the one that is being sent from the host is returned with ends with a carriage return, and the one that your device sends back has a carriage return and a line feed. So over here, this termination type 1 is for termination characters. Over here, see, I clicked on termination character. So now this one will be basically how many number of characters you want for your termination character. So over here is 2 because you want both. This delimiter you can set for both carriage return and line feed, or just carriage return. This is up to you. So I'm just showing you with both. Okay, so this one in decimal format will be 1310. Okay, and these three you don't need if you're using termination character, so you can ignore these three. And once you set this up, that's about it. And you need to, this is the IP address you need to set for your gateway, and then you're just, once you have that done, you just go download to the device. So now I'll show you an example from the project, like what you have to do for transmitting and for receiving. So over here, as you see, this is this example over here. So I assume this R and A is ASCII characters, but if it's not, then you would put the respective character over here. So assuming it is R and A, then this is RA character return here. So I'm sending from the gateway to your device. So this, and so in order for sending, so basically whenever the sequence changes, this transmit sequence, there will be a new frame sent. So you can, whenever you want to send a new frame, you can configure your PLC ladder to change this transmit sequence. Okay, and this count value basically determines the number of characters you want to send from this data, extended data. So right now I'm sending these 3. Okay, and so when so over here right now I have connected to a sort of a simulated sleeve. Okay, so in this simulated slave, whenever I receive this sequence, I return this, which is similar to that example in your PDA manual. So like this basically. So right now let's say I change, this will trigger this return message sequence to be sent back to the gateway, like how this would, like how your device would, like this frame. Okay, so now this frame will then in return be stored over here. So as you see, this is the entire frame over here. This is the range return, the line feed, the RA, and these are just the values I put. So basically so now you would want to be interested like how to know when you have received a new frame. So like similarly to the transmit sequence, this receive sequence will determine if there's a new frame entering. So you can have your ladder to monitor this tag to see whenever this is changing, then there's a new frame. So you can just copy this to a frame and paste it to another buffer tag, or utilize it however you desire. Okay, so now similarly for the others is pretty much the same. So like for example for this, you just change this bit, this whatever the values in the frame that's been transferred. Okay, and again just change this if there's more number of bytes being transferred in the frame, and then every time you want to send, you just change the sequence, and if your device recognizes that frame, it will then respond accordingly and send you a frame in return. And then in return you can use that data however you want to. And yeah, that's about it. Alright, thank you.